Hello, Rocio. Okay, sorry, this is about my fourth or fifth attempt at this video. I keep stopping halfway through and thinking, no, I just want to restate that in a slightly different way. I'm going to go slightly off on a tangent just to remind you first about what integration actually is. Essentially, it's the area. You're finding the area underneath a curve by subdividing it into an infinite number of infinitely thin rectangles. And that's why we can look at the area as roughly equal to all these y coordinates. They're just the height of our rectangles, and the dx is just going to be the width of each rectangle, and always all going to have the same width, delta x. Remember, delta really stands for an infinitely small change in x, and we're just going to multiply them together. So we get y1 delta x plus y2 delta x all the way up to y delta x. Now you can write that in various ways. You could write that as a sum from k equals 1 to k equals n of y xk delta x, where delta x is of course b minus a over m, because that will tell you how many rectangles you're actually having between those limits. And we can actually write those both down in limit notations. By the way, just as a little heads up, that's the way they like to write it down in A level. You need to recognize that as the limit definition of an integral. But that looks a lot more like the Riemann definition of an integral, which you'll meet at university. Okay, I don't want to get too much into that at the moment. I'm very happy to get into it, maybe in another video. I might well do another video in a minute of how we get to this, but I suddenly realized I was going massively off topic for the question that you asked me. But the key thing is, that's why we're going to get a positive area when the line is above the x-axis, whereas when the line is below, and let me just, that relates to your question in a second. Naturally, what are you actually doing? Well, if you've got negative y values for the curve when you're going below, all of your y coordinates are going to be negative in your summation. Let's do the summation one, because you're doing y times delta x. All those y's will suddenly be negative, and hence you get a negative area when you're underneath the x-axis. Negative, good. So bear that in mind. Once it's below the x-axis, you're going to get a negative area. Now, why does the ellipse cause problems? Well, the ellipse isn't the only function which causes problems. In fact, any function, and I put that word in inverted commas because it's actually a mapping, any graph which is one to many or many to many is going to cause trouble for integration. So let's just take a related problem. Let's just take something like the square root of x. Y equals a function which is one to many. One x value gives you two different y. If we call it minus the square root of x, that should be good for us. Okay, let's do it in two different ways. Or let's look at it in two different ways, should I say. If you only want to integrate the function y equals the positive, and I'm actually going to write down the positive. If you just wrote down y equals root x, by the way, here, Rocio, that would be fine, and that would, let you know that root x is defined to be positive root x. It's the same thing, but I just wanted to make it clear that I'm only dealing with positive square root values. Then you're okay, because that's a one-to-one function, and so when you integrate it, no problem at all. It's going to look something like that, the curve, and say you were to integrate root x, x to the half, between 0 and 1, you're going to get x to the 3 over 2, 2/3, between 1 and 0, and no problem, you get an area of 2/3 for that first area between 1 and 0. Cool. Okay, and it's positive. Well, why don't you get the negative area? Well, it's because you're not actually dealing with plus or minus root x. Yeah? Oh, that's a different shaped curve. That actually goes down here. Now, how do you tell the integral which y coordinate to use? Yeah? How does the integral know whether you're dealing with the positive y coordinate or the negative y coordinate? Well, x to the half is also, ask your calculator, taken to be a one-to-one function. Your calculator doesn't tell you two answers when you type in 64 to the power of a half. It tells you it's positive 8, not negative 8. And if you want your calculator to know that that should be a minus, then you need to put a minus before it. Yeah. So it's about how people interpret the different symbols that we have. So if you want the negative answer out of this, well, when you plug in that 1 into there, and you do square root, which is what that power of a half means, you then need to tell him tell yourself that it's negative, and then you'll actually get out minus that answer. So that's the first thing to note. Whenever you're dealing with one-to-many functions, you need to bear in mind with your notation which y coordinate you're taking, the positive y coordinate or the negative y coordinate. It really is down to that. Now, our problem which we're dealing with here is no different. We've got a parametric equation, and I wanted to point out straight away, your values of theta will depend on where you are on the curve. So if we do the sort of classic ones, 0, pi over 2, pi, 3 pi over 2 and 2 pi, then we can see this as a lived curve, which is how you should always view a parametric equation, like as something which moves you around the curve. Now, when x is 0, we're going to get cos of 0 is 1, so x is 4, and sine of 0 is 0, so y is 0. Pi over 2, so we know that that's, by the way, 4. I think you already know that this is 2, because when you're dealing with pi over 2, cos of pi over 2 is 0, but y will end up being positive 2, and so on and so forth. So we're going to get minus 4 for this one, and 0, and then we're going to get 0 and minus 2 for this one, and finally we're back to 4 and 0 over here. Now, to show you what that actually looks like, if I can just bring up my GeoGebra. Okay. Oh, I had it there, 1 second. Okay, what does that create? That creates a curve that looks like this. The ellipse that we see. By the way, as I'm moving A there, I'm moving theta. So theta is 0, theta is pi over 2, it's about 1.5. Theta is pi, that's 3.1415. Theta is 3 pi over 2, and theta is 2 pi. Okay, all well and good. Now, how does this work for us? How does this affect our parametric equation, and how are we going to tell, because this is crucially your question, how do you know if the answer should be positive or negative? Well, you need to draw a diagram. That's what I would say to you. You need to draw a diagram. But look at what you've also changed the problem into, and it should help you. So you wanted to know why, essentially, why when we change our problem from this one into this one, I'm going to write them down. It's a great little investigation you've got going here because it will help you understand it. We were essentially integrating y with respect to x, or not the curly one, I don't want the curly one this time anymore, y with respect to x between 0 and 4, because when we were here, x was 4, and when we're here, when we've got all the way from there around to there, x is minus 4. So actually, because that's what you want to do, I think, pi from 0 to pi, yeah? So our highest value, if you like, is x is 4, and our lowest value is x is minus 4. Now, if you do it like this, you're going to get a positive answer. And that's because the equation is essentially taking the positive y-coordinate here, not the negative y-coordinate. Now, if you work through it like this, if you always ask yourself, well, how does it work in Cartesian form, and you put the lowest y-coordinate there and the highest y-coordinate there, you should end up with a positive answer if you do it carefully. Now, just remind yourself why this actually turns into 8 sine squared theta. We had x was 4 cos theta, y is 2 sine theta, and as you know, this is the same as y dx by d theta. Now, dx by d theta is where you get the minus 4 sine theta coming in. So we're going to do 2 sine theta times by minus 4 sine theta d theta. But remember that these limits are in terms of x, and when you switch them, we're going to get, when x is 4, cos theta is 0. Yeah, theta is 0, sorry. And when x is minus 4, we get cos theta is minus 1. So that's where you're going to get pi. And so we end up with between 0 and pi, and this is a substitution, so we shouldn't swap those limits because we think, oh, pi is bigger than 0, I should swap them. No, you're going to write that as minus 8 sine squared theta d theta. And then I think I showed you the trick about if you ever swap limits round on an integral, it's exactly the same as the negative of what it was before, which is what they require for this question. You do need to swap the limits round to make that pi and 0 positive 8 sine squared theta d theta. Now you might think, why is this going to give me a positive value? Well, I can give you several good reasons. Here's a graph of positive 8 sine squared theta. Yeah, this is y equals 8 sine squared x. If I ever integrate this and I make sure that the lower limit is smaller than the larger limit, I'm clearly going to get a positive value because the curve lies above the x-axis for all values of x. And that's because we're squaring sine x. So if I square sine x, I'm going to have a positive value, and, etc., etc., really. So yeah, that's why we're definitely going to get a positive value there. But in answer to interestingly, as long as you're taking values of x, sorry, my kids are banging on the shed door. As long as you're taking values of x which are larger at the start and at the end, it depends actually the direction you're moving around the curve in. Let me actually show you it from the parametric curve. As long as you're passing round in a positive direction round here, you're always going to get a positive value. So if you go from 0 to pi over 2, or pi over 2 to pi, or pi to 3 pi over 2, or 3 pi over 2 to 2 pi, you're going to get a positive answer. And so actually, we could have done this question just by from 0 to 2 pi, 8 sine squared theta d theta, and that would have given us just 8 pi without cancelling anything out, without the area above cancelling out with the area below. It's going to work like that as long as you're going in that kind of direction, in an anti-clockwise direction. Is that anti-clockwise? Yeah, I think it's anti-clockwise. It's because you're of the way you've defined x and y there, because you've let x be cos theta and y be sine theta, and you can see it from the equation, from the parametric form from the Cartesian form. The parametric form is clearly above the x-axis and positive for all values of theta. So as long as your lower limit theta is smaller than your upper limit theta, you're going to be absolutely fine. But you should be really careful on those. I completely agree that it is confusing, and it's the very reason why the question suggested just take the first quadrant, because many to many mappings, they don't work well in integrals, or they can cause confusion in integrals. Why do they cause confusion? Because of the nature of having one x value generate a positive y value and a negative y value. So yeah, be very, very careful. I hope that's helped. And I've also sent you a link for the integral with the limit definitions, because I think it is an important topic. And so yeah, the link is just here. I'm just showing it here. I'm going to send you a link of that as well. It's the reason why that helped Rocio. Yeah, best of luck with any more. Again, if there's anything you don't understand, and I'll try and give you another explanation. Okay, well done, and keep up the hard work.